on Meetup. We have Slack if you want to do any real-time messages. Everything's recorded and posted on our YouTube. So if you ever want a refresher or send it to somebody who maybe couldn't make it today, or if there's any meetings in the future you can't make it to, feel free to check it out there. As always, any feedback or topic suggestion or questions, also feel free to reach out to any one of us individually, and we'll do our best to answer those questions for you or find somebody who can. Today, we are getting a talk on Data Factory and Power BI. The 19th will be over Kubernetes Part 2. And then that should be, that's a typo. The next Tuesday after that will be Azure App Logging. There's free resources to learn more about Azure. And today's sponsor will be Xeris. And with that, I will pass it over to Bruce.
Thanks, Alec. So Xeris has been a consultant for over 30 years, focused on primarily the non-coastal regions and helping customers solve business problems. And today we're going to be talking about Data Factory and Power BI and how they go together very well in solving customer problems. And I'll hand it over to Tyler. And at the end of this, we'll be giving away a $25 Amazon gift card.
And you must be present to win. Hang on to it.
Right.
Thanks, Bruce. And let's see, can you all see my screen? Awesome. All right. Well, thank you everyone for joining us today. So the reason we created this presentation and demo is because there were some common roadblocks we heard over and over from clients who wanted to do advanced analytics and machine learning, but were hesitant to start. The goal of the presentation is to give you all a better understanding of how you can use Data Factory and Power BI together, unifying cloud and analytics to get the most out of your data. The goal of the demos is to give you the ability to do some basic ETL in your own data factories, as well as use Power BI to analyze your data and build machine learning models without requiring any code. On that note, let's get started. So this is the agenda for today. We'll cover common roadblocks, as I said. We'll get into a use case with a bank and how leveraging Power BI can help them. We'll cover the general architecture, a demo, and then we'll recap everything. So there are a couple common roadblocks we've heard from a ton of clients as we've been doing analytics consulting, especially with regards to machine learning and data transformation and these types of things. One is that, well, we don't have the capacity to do high compute operations. They just are doing everything on-prem, and I'm sure like this is the Azure user group, so we don't really need to sell Azure to you, but it's a thing we've heard from a lot of clients. Or our current tool takes too much time. One client we talked to was doing everything in Power BI, like Power Query and using that for the data transformations. And it was just too slow. It took a lot of time, and so we have a solution for that. We can't do machine learning without a data scientist is what we've heard a lot of times. But really, there are a lot of tools now, including Power BI, which really help you build out your data science practice area and don't require a lot of coding, if any coding. And so it really allows you to use machine learning effectively. Or in a similar vein, well, you need to know how to code to create machine learning models, either R or Python or Scala. But really, again, that is going to a wayside, and there are some solutions that no longer require coding. So for our use case is this bank that is basically starting campaigns or has been doing campaigns where they get a list of people that might be likely to open an account at the bank or who they hope will open an account at the bank. And basically for everyone on the list or however many people they can handle, they need to call that person and then talk to them for a certain amount of time or don't talk to them if they don't pick up and hopefully get them to open an account at that bank. Of course, they have to do this for as many people as they can on the list or as many people as they deem suitable on the list. But right now they're doing it very naively. They aren't using any advanced analytics to do it. They're just going down the list in order. The data they have, though, so they have some data about the people on this lead list. They have information about their demographics and personal information, such as these people's ages, their education level, do they currently have or own a home? And they also have information regarding historic campaigns that they've conducted with these people. So things like how were they contacted? What month were they contacted in? And importantly, they have whether or not those people opened an account. And so this is the key thing we want to train the machine learning model to predict. Based on all of this information we have, is a new person likely to open an account or not? So what does the analytics driven solution look like for this? Well, first we need to combine these two data sets. So for this guy, we could have his age and his career and education, and we'll combine that with previous campaign information about him as well. And then we can feed that into a machine learning model. So the first step, of course, is to train the machine learning model on historic data. But then once we have a trained machine learning model, we can predict for new possible customers. So we send that through the model, and we could get something like, oh, this person has a 65% likelihood of opening an account. And then we can tell our customer service reps, let's reach out to him. Let's call this person. That seems like a hot lead. On the other hand, we could get a prediction from the machine learning model that he has a very low likelihood. It could be 30%, it could be 15%. And in that case, we wouldn't need to waste our time calling them. The customer service reps could spend their time with other more likely clients in order to save money. So how can we accomplish this? The naive way, or one basic way to do it, is to use Power BI Premium. Power BI Premium has automated machine learning built in now, where all you have to do is tell it what column or what feature you want to make your prediction on, and it will automatically train dozens of machine learning models and be really easy at deployment. However, with one client we talked to, they were using Power BI Premium, but they were using it to do everything. So they were pulling data in from their raw data sources, and they were cleaning it up in Power Query, and essentially then building the machine learning models. But they were doing so many operations in Power Query that it took a lot of time to do ETL in Power BI. It was basically using all of Power BI's compute resources and kind of bogging everything down and limiting everything else Power BI could do. So the solution for this is to leverage another one of Azure's or Microsoft's products, Azure Data Factory. So in Azure Data Factory, you can actually leverage it to do ETL or ELT or ELTL, whatever your process is right now. But with Azure Data Factory, it's basically using the right tool for the job. And then you can use the power that's left, or you can use all of Power BI Premium's power to focus on machine learning or building dashboards or deploying models, that type of thing. So what does the architecture for this solution look like? Well, in this case, we have a CRM that has customer demographics in it, and we have an Excel spreadsheet of previous campaigns. Now, of course, the Excel spreadsheet isn't great, and ideally we would convert that to something more cloud-based or at least a database. But basically, the first step would be to pull the data into Data Factory, or Data Factory would connect to these data sources, and Kayla will show how to do that in her demo. But basically pull the data into Data Factory, do some transformations prior to joining the datasets, join the datasets, store them in a MySQL table for our demo. Of course, you could store them in any structured database or in blob storage or any staging way, or any way you can think, basically. But that way, there's a place for Power BI to connect to that clean data and pull it into the Power BI workspace, where then Power BI can train machine learning models, deploy them, and you can easily build dashboards related to those data sets. And on that, I will hand it over to Kayla to cover this first part of the demo. If I can figure out how to stop sharing. There we go.
Great. So to reiterate what Tyler was saying, let's see. The reason that we want to show Data Factory today is to illustrate how you can use a real ETL tool to do ETL instead of using an analytics tool like Power BI, which isn't well suited for that. So right now, I am starting on the Azure Portals homepage. And for this particular demo, 3 resources are required. We have our Data Factory version 2 resource, a storage account for Azure Data Lake Storage Gen 2, and this is holding our raw bank data, so both the customer data and the campaign data that Tyler mentioned. And then we have an Azure database for MySQL Server resource, because we will eventually be putting that data into a MySQL table. So now we can go ahead and jump into Data Factory. So I will just select my recent resource, and then I will select Open Azure Data Factory Studio. When this loads, we'll be on the home screen. And on the left, you can see that there are 3 other options. So there's the Author tab, and this is where we will create our pipelines. Monitor is where you will view executions of those pipelines. And then Manage is needed to control some connections and securities. So if we go to Manage, there are 2 things that you need to set up in order to execute Data Factory pipelines. The first being linked services. Linked services hold the connection information for data sources. So you need a linked service for each data source that you are going to work with in your pipelines. For this demo, we have 2 linked services. We have one for our Azure database for MySQL and one for our Data Lake storage account. We set these up ahead of time just to save some time, but they do need to be created in advance of creating your pipelines. The other thing that needs to be set up is an integration runtime. Integration runtimes specify the compute resources used to execute a pipeline. So your company can specify this to either increase compute power or save on cost, just whatever works best for your use case. There are 3 types of integration runtimes. There's Azure, Azure SSIS, and self-hosted. Azure and Azure SSIS use cloud infrastructure, while self-hosted will use on-prem resources. Azure will always provide you with this default integration runtime. And for this demo, we're fine with that. So we're going to go ahead using this one. So now that we've discussed linked services and integration runtimes, we can move to the Author tab and begin working on pipelines. So you can see on the left, there are 5 resources. Pipelines are a group of processing steps that perform a task. So to remind everybody, our task in this demo is to take raw bank data, transform it, and then move it to a MySQL database. This is the orchestration piece of Data Factory. Next, there are data sets. So these are your data sources and your data destinations. Data flows are where transformations can be done. Power Query is another data transformation tool, and it's the same one that you can use in Excel and Power BI. And then templates store predefined pipelines in case you don't want to rebuild one from scratch. Okay, so for this demonstration, the first thing that we want to do is establish all of our data sources and our data destinations. We do this under the dataset section. So when I expand this, you can see that I already have 2 created. I have demo customer data, which is our raw bank customer data. And then I have demo SQL table. So this is our MySQL destination. So the only one that I still have to connect to is our campaign data from the bank. So to do this, I can go to Actions and select New Data Set. And now Azure is showing all of our, or Data Factory is showing all of our source options. There are over 90 connection options inside of Data Factory, with more always being added. And in this case, our campaign data is stored in an Azure Data Lake Storage Gen 2 account. So for that, we can select Azure from the top. And then we can select the appropriate data lake option and hit continue. Next, it wants to know the format of our data. So in this case, we are working with a CSV just for the purpose of having a more simple demo. So we can select delimited text in the top right and hit continue. Next, you always want to give your data sets descriptive names so that you know what you're working with. So we can call this demo campaign data. Under linked service, you will select the linked service corresponding to the location of your data set. So we select the one that corresponds to the proper data lake storage account that we're using. Now we need to specify the file path. In our case, it is in the banking demo container, the raw data folder, and the file is called bank campaign data.csv. Next, we have first row as header, and we are going to select that. That just means that the first row in the file contains all of the column names. And then import schema, we're going to leave it as from connection store. That just means that when possible, Data Factory will infer the schema. So now we can hit OK. And we're done creating that data set. So on the left, you can see that we have our two source data sets, our campaign and our customer data, and we have our data destination. So there's nothing else that we have to do there. This means that we're ready to move on to data transformations. We're going to be using data flows to perform those transformations. So again, I can go to my data flow actions and select new data flow. First thing that you need to do is, again, name it. So we will call this demo bank data flow. OK. Now we add in all of the data sources that we want to build transformations off of. So I'll select add source. And this first one can be my bank campaign data. And under this data set option, it'll give us a drop down of all of our data sets. So I will just select the corresponding campaign data. Everything else we can go ahead and leave as default for this demo. So now I'm just going to do the exact same thing, but for the customer data. So call it bank customer and select the demo customer data set from the drop down. OK. So now we have our two data sources in here, and we can begin any transformations. So in this case, let's focus on doing transformations to our customer data. When we select this arrow in the bottom right, it'll show you your transformation options. And the first one that we're going to do is going to be a row modifier, and it's going to be a filter. So I'll select filter. And we will say that banks don't want to advertise to anyone under the age of 18 because they cannot open an account on their own. So we'll say filter out under 18. That's just telling myself what I'm doing so I can glance at it and know. And then in this filter on section, I will click inside this box and I get this new option to open expression builder. So I'll hit that. And now in the expression builder, it's showing me all of the columns I can work with, as well as functions that I can use. So these are the columns from the customer data. And since I said we're going to be looking at age, I'll select age. This ABC to the left of age is saying that right now, Data Factory thinks that age is a string. So the first thing we need to do is we need to tell Data Factory that age is actually an integer. Next, we're saying we just want to filter out anyone under 18. So we can just go less than 18. And that's our entire expression. So now we can save and finish, and our filter is done. Let's also show how to create a new column entirely. So again, using our plus option, now we're looking at schema modifiers, and we'll be using a derived column. In our customer data, each customer has a bank balance, and this can be a wide range of values, but maybe the bank doesn't care what the exact value is, and they just want to know whether or not the balance is negative or positive. So we're going to be creating a column based on the balance category. So again, the output stream name is just for us to reference, but then under columns is where we will say what we want the new column to be titled in our data set. And I want it to be balance underscore category. When I click in the expression box, I can once again open the expression builder. And this time we'll be working with the balance column. Once again, we need to convert it to an integer. And then I already know that I want to use an if statement, which happens to be IIF in Data Factory. You can hover over functions in Data Factory and it will tell you how you need to format them. So in this case, first you need to specify the condition, then what you want the column to be if the condition is true, and then what it should be if it's false. So let's say that we're just going to check if the balance is less than 0. If so, our new column should just say negative. Otherwise, we'll consider it positive. That's our entire expression. So again, we can hit save and finish. And now you can see when I hover over our initial customer data, we started with 9 columns, we filtered, and now we have 10 columns. So those are all of the individual transformations that we're going to do to the customer data. And now we can join our 2 data sets. So from here, we'll select the multiple inputs, outputs, and the join option. And we'll call it join bank data since we are joining the customer and campaign data. The left stream is the output of our transformations on the customer data. And then for the right stream, we will just select bank campaign. We can leave it as an inner join, and now we need to specify the column that they have in common. And in this case, they both have a column called customer underscore ID. So I will just select that for both of them, and our join is done. The final thing that we need to do inside of our data flow is move the data to our MySQL table. So for that, off of our join, I will select a new action, and I'll scroll down to destination sync. And we will call this move to database. Our incoming stream is the data that we just joined. And then for sync type, we're going to change this to inline. The reason for this is that because some of the data that we are working with is inside of a CSV isn't able to store the metadata to tell you what the data types are. So by selecting inline, we're allowing the MySQL database and MySQL table to define those data types. So in our inline data set type, I will select Azure Database for MySQL because that is the type of database that we are working with. And then I will select the corresponding link service that we set up ahead of time. So ours is called ADF MySQL. And that's all we needed to do. So this is our completed data flow that will take the bank, campaign, and customer data, do some individual transformations, join them, and move them to a MySQL database. However, you cannot execute this data flow from this screen. To execute this, you actually need to create a pipeline. So to do that, I will move over to pipelines and select the new pipeline action. Again, give it a descriptive name. So I will call it demo bank pipeline. And on the left, under this activities section, you can see all the different categories of pipeline activities that you can use. Some of the more advanced options include for each activities that can loop through multiple data sets. There are Databricks activities to execute existing Databricks notebooks or to move Databricks process to the cloud. And there are Azure machine learning activities where you can use your deployed machine learning models to generate new predictions. For this demo, we want to keep it simple. So we only want one step, and that step is to execute the data flow that we just created. And that is under Move and Transform. So when I expand this, I can either copy data or data flow. So I will drag this data flow activity onto my canvas. Again, the name just tells us what we're working with. So we are using the demo bank data flow. And then we can go to the settings tab, and all we need to do in this data flow section is select from the dropdown the data flow that we just created. We don't have any parameters, so we don't need to do anything with that. So this is our very simple pipeline that will run the data flow that we created. Now, whenever we want to, we could execute this pipeline manually, or we could also add a trigger here in the middle right, and a trigger could make this process run automatically based on either time events or storage events. So you could say, run this pipeline every day at midnight, or you could say, run this pipeline every time a new file gets added to a certain folder location. Those are just a couple of examples. So again, the purpose of this demo was to show you a simple process that you could recreate on your own without any prior experience. To show a more advanced example of using Data Factory for efficient data transformations, Tyler is going to step through one of the recent clients that we have worked with.
Thanks, Kayla. Yes, as Kayla said, I will show you an example of something we did for a client. So this is a screenshot of something we did for a client where basically we had a handful of tables that they wanted to join so that they could do some machine learning on the data that was in those tables. And so with this, we have 5 tables we can see here, and there are some below the screenshot that it just worked better for a screenshot to do it this way. But basically taking the dates and areas and divisions and those types of things, joining them together, filtering them and merging them, and then basically storing them in a SQL table so that we could access that through a different platform to do machine learning on it. And that way we didn't have to, or we had the ability to leverage Data Factory's power to do all those joins and merges here. We were also able to schedule it using the trigger to run nightly. So every night our data would refresh and insert more data into the SQL table. But on that note, I guess we can move on to the Power BI section of the demo. So here in this part of the demo, we will connect to the customer data table from Power BI and run through Power BI's automated machine learning tool. So here in Power BI, we have our Power BI workspace, and we'll just I've created every step ahead of time because Power BI usually takes a few minutes to confirm and validate each step. And so just in prep for that, so we don't have to sit around waiting for stuff, I've made all of the steps independently so we can just step through them easily. But the first thing we want to do is make a data flow here in Power BI to connect to our data source, our MySQL database where Kayla landed the data. So we'll go here to define new table and select add new table. And now we'll be able to see all of the different data sources Power BI can connect to raw. Now, of course, or I guess this isn't nearly as vast as Data Factory, but it's still pretty diverse. And it covers things like lots of Azure data sources, a bunch of different databases, or things like CSVs or APIs. But we'll just go to connect to the MySQL database. And here, this is just where you input your connection information to the database, and you'll have to select a gateway because this one happens to be set up slightly different. But then basically after you input all that information, you just select your table on the next screen. But I'll move on to the next step. So if we go back to here, basically that would be the ingestion step. Now, one of the best practices with Data Factory is to have one data flow, or not Data Factory, I'm sorry, with Power BI is to have one data flow that ingests the data from your data source. That way it can be pulled into Data Factory, into Power BI, and you don't have to keep pulling it in every time you make a change in your data, in your Power Query. So here, if we look at the data we have in this ingestion data flow that's connected directly to MySQL, it takes a second to load, or well, I guess it normally takes about 20 seconds. So I guess that should be soon. There we go. So now we can see we have the 19 columns that Kayla joined and created. We can see we have the previous campaign data, the information on the people, and then we also have the balance category, the new column that Kayla created. And importantly, we have opened account, which again is what we want to try and predict using our machine learning model. So the next step of this is basically to build a data flow off of that references it. So we'll go back to data flow, and that way we can make any changes or build any machine learning models without having to pull data back in. Oops, I guess I should have shown that or specified what I was doing. So here we want to go to link tables from other data flows. And so this way we can connect that data flow we already made, or we just made. And here we don't want to use a gateway this time, and we'll have to sign in again. And then we can just continue. And this time we'll select our workspace, and we'll select the data flow we use for ingestion, and we'll select the table that we picked there. And we can go to transform data. It also gives you a preview here to make sure you've selected the right table. And so here we can see this data again. What we need to do now is we need to reference this data so that we can make changes to it. If we didn't reference it, because it's already in another data flow, we wouldn't be able to make any changes. So we just reference it. And because Kayla already did a lot of data prep and cleaning, like removing the under 18 people, we'll just go ahead and call this campaign data clean. And then this is what we'll reference to build a machine learning model with. And we'll go ahead and move to the next step after this. So the next step, once your data is prepped and ready for the machine learning model, is to go ahead and go to your data flow with your clean data and click on machine learning models up here. And it gives you an overview of the machine learning process, but we can just go ahead and click get started. So first we have to choose a table, and so we'll choose the clean data, and we need to choose the outcome column, so what we're trying to predict. And like I said, we're trying to predict whether or not someone is going to open an account. And we'll just go ahead and click next. Now, there is some data science knowledge that is required to use Power BI's automated machine learning effectively. So one thing is knowing what type of prediction you want to make. It does give you a hint here, or a brief overview of the types of predictions you can make. And we can see already that we can't make a regression prediction or like trying to predict a numeric value because there aren't numeric values in the column we selected. However, it didn't fully load a data preview, so we have to select what type of classification problem we're going to make, or classification model we're trying to make. So one type is general classification, which could be like, which of the following are we trying to predict? And you can see here, it gives you some examples to help you. But in our case, we're trying to predict yes or no for opening an account, which means we would be making a binary prediction. We also need to choose which of the outcomes is more ideal, or like what do we want to know more out of this. And so really we want to know who we should call, who is yes likely to open an account. So we'll choose that as the main outcome that we want. And then also we can change the mismatch label to no again. And we just have to hit next. And So now Power BI will, luckily it was able to load a preview of the data, so it's done some analysis for us on what's likely to be useful to the machine learning model. So here, like P days or prior days, it has analyzed it actually has low correlation with our target column. So it's already deselected that for us. So that way it can use compute on things that it finds more valuable or that it thinks could be more valuable. However, this time we'll just go ahead and select everything except for customer ID, because we know that a customer's ID number actually has no correlation with how likely they are to open an account. Then we just have to select next, and we can name the model. So we'll just call this conversion model. We can give it a description, and then we can select a training time. So we can select from 5 minutes all the way up to 6 hours. And one of the best practices is to select 5 minutes the first time you train the model, just to make sure everything is set up and working and you don't wait 2 hours and find out, oh, you selected the wrong column or something didn't work right. So the best practice is to start at 5 minutes and then after the first run, select however much time you have. Now, of course, with more time, it will give Power BI the ability to use more data and to train more machine learning models to evaluate them. But after that, all you have to do is click Save and Train, and it will get going. And so once your model is trained, the next step is to evaluate that model. So we'll go to this model we've already trained, and we can see Power BI has created some training data and some testing data automatically off of our source data. But we just go back to machine learning models, and now we can select this model report, the training report for the model. Sometimes this takes a few minutes to load, and so if it does take a little too long, I have it open here. But this is another point where a little data science knowledge can be really helpful in evaluating your models. Of course, we can educate you on that if you're interested, but really, one of the things is this thing called, well, I guess basically we can see our model has essentially a 91% accuracy. We can think of it that way. But we also get this useful thing called a confusion matrix here because the machine learning model is predicting a value from 0 to 1 of how likely someone is to open an account. We can change the threshold of what that 0 to 1 value is. So by default, it's normally 0.5, where anything under 0.5 is classified as a no, and anything over a 0.5 is classified as a yes. And by changing this threshold value, we can change the likelihood of false positives, false positives, false negatives, true positives, and true negatives. So in this case, we have predicted yeses that are actually yeses. We have predicted no's that are actually no's. And then we have incorrect predictions here. So predicted yeses that are actually no's and predicted no's that are actually yeses. So if we adjust this threshold, we can increase recall. And just to note, we have about 950 good predictions and about 1,700 incorrect predictions here. So if we adjust this threshold, we can then get more actual yeses, but a lot more actual no's. So we go from 950 to 1,000 yeses, but we go from 1,700 to 3,000 no's or incorrect predictions. We can also adjust it the other way. So if staffing was really short, the bank might be interested in actually getting more accurate predictions. And so if we raise this value, now we can see the correct predictions decreased by about 200 from that original value, but the incorrect predictions decreased by about 1,000. So with that, they can get a lot more accurate or a lot more precise model. But figuring out this number is a little bit of a guessing game and just seeing where things end up as you move this around. But Power BI Premium has this really useful cost-benefit analysis tool built in. So if you know the population or the number of people that are in the campaign, and you know how much it costs to reach out to someone and what you stand to gain from reaching out or from an opened account. So in this case, we'll say it costs $5 to reach out to someone and $20 if we stand to gain $20 if they open an account. We can see that really the best value here is right around here at 0.71. And it tells you this here, that this would be the best value to maximize your benefit from this model. We can also change these values. So if it costs $10 to reach out to someone, we can see that this chart automatically changes. And really the best now is 0.89. So basically by increasing the cost, you want to decrease the false predictions. But we can change this to 0.71 now. And we can see with our original cost of 5 and 20, this is the best value or the best bang for your buck, basically. Now, once you've figured out this threshold, there are 2 more training reports, an accuracy report and training details, but this is just some back-end stuff about what's going on with the models. We won't get into that today, but it's good to know it's there. But to deploy the model, all we have to do, once we've decided this, all we have to do is select Apply Model, and we can select a new data set that has gone through all of the same transformations using Data Factory again. And we'll name the prediction column, and then we need to set our threshold. So we'll just go with 0.71 this time. Now, all we have to do is click Save and Apply, and it will deploy the machine learning model to Power BI Premium. So unlike a lot of Azure services, everything is self-contained in Power BI Premium. You don't have to specify what storage you want to use, what compute you want to use. You don't need to say what container you're storing your model in. It's all built into the cost of Power BI Premium. Oh yeah, and another good point is that Microsoft recently released Power BI Premium per user, where it used to be an enterprise product. It now is available, I think, for $20 per user per month to be able to build machine learning models in this way. And there are some other benefits too, but we're just focusing on the machine learning models in this case. So one really great thing about having your models in Power BI already is that the Power BI is basically a visualization tool for showing your data. So here we can have our campaign predictions, and we can see with that threshold of the predictions for our data, we basically have 19% of our data, or 19% of our people are predicted to be yeses. And about 80% are predicted to be no's. We can see that's about 3,500 people instead of the original, I think it's like 20,000 or whatever that math works out to. What's this? 14,000 plus 17,000 people. But we can also select the yeses here, and we can see, we can do some analysis right now and see that there's lots of people that aren't predicted, predicted to be yes under 60, but once we reach 60, almost everyone who's reached out to opens an account. So maybe that's a sign that we should contact more people over 60 because they appear to be more likely to open accounts. We can also see that people with management careers are also more likely to open accounts than blue collar workers. But really, what we want out of these predictions is the lead data. So if this data wasn't anonymized, we could have a table here with all of the contact information of the people. So we could have their customer ID, we could have their phone number, their name, their preferred contact method, lots of stuff like this. But right now we just have it filled with some of their demographic information. And we also have the raw prediction here. So of course the model makes a prediction yes or no, but also it gives a likelihood from 1 to 100 or 0 to 1. And so we can see that here. So we can see there's a handful of people, around 70-ish, but we might want to focus first on the people that are most likely to open accounts. So we can just select that and sort by raw prediction, and then we can easily start at the top of the list where the people, according to the machine learning model, are most likely to open accounts with this bank. Which can make it a lot easier for the customer service reps. And on that, we will go back to the presentation. So hopefully that gives you a good idea of how you can use Power BI and Azure Data Factory to better leverage advanced analytics at your business. But today we covered this use case with this bank and how they can target people more effectively to open accounts. We also covered the architecture of how they can do that effectively. Additionally, we covered a real example of how we did this for a client, how we leveraged Data Factory. And we covered how this can overcome hurdles that we've seen other clients experience. With that, are there any questions?
Don't see anything in the, Nick's got his hand up, so.
Hey, Tyler and Kayla. If I wanted to share that report with someone who wasn't within my organization, are you familiar with how best to do that? Preferably, I would like to put some slicers in there and still have them have some data behind the scenes. They don't necessarily have to have access to the database, but I mean, I didn't know if there's any way to I guess import that data into something that's shareable with someone who even has something not necessarily like a Yahoo account, but typically whenever I share reports with people, it has us, even if I set up a guest user, it has us basically have them log into their, it requests the work email address, and then it requests a password.
Yeah, one requirement of Power BI or of automated machine learning in Power BI Premium is that anyone who wants to see the machine learning model or the machine learning predictions is also required to have a premium license. I think there are ways to manually export, like you could open the report on your desktop and manually export the data, but really it seems like it's a lot of work to do it that way as well.
All right, thank you very much.
Yeah, sorry, there's not a great answer to that.
Yeah, if you wanted to, you could just create the report in Power BI desktop initially and then share the report in any way that you would normally share a desktop report compared to a Power BI service report. And then if this was a widespread distribution, you could use a tool called Power BI Embedded, where you can embed these reports into applications for other people to view it. But I think in your scenario, if you're saying you would just be sending it to one person, I don't think that's quite the proper use case for that, but that is another solution.
Thank you.
Ricardo, do you want to ask your question?
Yes. Can I have a pipeline triggered by the results of my machine learning?
So the machine learning options in Azure Data Factory are related to Azure's Machine Learning Studio, the new Azure Machine Learning Studio, and also the pipeline, but also standard Azure Machine Learning deployments. And so you could have a pipeline element that is basically an if statement where if the prediction ends up positive or negative or whatever, however the prediction ends up, you could continue the pipeline from that, or you could follow a set of steps from that pipeline. Does that make sense? Yeah.
Yeah, I see.
Okay.
Thank you.
Yep. Nick, were you the first one, or was Nick the first person who asked a question?
Yeah,
Let's
Nick
see.
was the first.
Okay,
person.
cool.
I can go ahead and stop the recording. So if anybody wants to ask questions off the recording,